Okay. Difference quotient, which is this formula here. It's going to help us find the rate of change when x is 1 of this specific formula. Okay? Now, because it says f at this value, that means we're going to use this entire function and plug in a. A stands for where we are, so that's actually our x in this question. So I know they've written it as x equals, but it's essentially going to be what our a is in the difference quotient. So a will be equal to that 1, and we're going to plug 1 into each of those formulas. We're going to be using the formula twice. H stands for a number that is so close to a that it's pretty much going to be 0. Okay? The problem is h is on the bottom. It's divided by h, also this question. And we can't divide something by 0, become undefined. So the whole goal is to essentially cancel out this h eventually, so we'll find out what the slope is or the rate of change exactly at that point. Okay, so that's our goal here. So the very first one, we take our formula, our f at x. We have our function. So this is, we'll put it in brackets. We'll do the first one in red, okay? So this will be the one we do in red. This is 5. And we replace the x, the a and the x is 1. So actually, first I'll just do a plus h, so you get used to this idea. Squared minus 8 times a plus h. Okay, so that's the first part. The second part, brackets again, this is going to be this guy. We'll do him in blue, which is 5 times a squared minus 8 times a. Okay, and that's that part of the function. And then we divide it all by h. Now, our a value is 1. So we're going to replace all of the a's in this question with the number 1. Okay?
Yeah, that's what I did wrong.
Okay, so we have 5, 1 plus h squared minus 8 times 1 plus h minus, and we can actually work part of this out. 1 squared is going to be 1 times 5 will be 5, right? And 1 times 8 will be 8, so it's 5 minus 8. The second part's pretty simple. We've already got through it. All divided by h. From here, okay, let's keep going. Well, that's going to be 5 times 1 plus h times 1 plus h. And we'll FOIL that one out or distribute the 8. So that becomes negative 8 minus h. That's not an h. There we go. Minus h. Still in brackets. And all of that is going to be subtract negative 3, which is the same as just adding 3. Is that okay? So we have our h. When we distribute this here, we're going to get 5 times h squared plus 2h plus 1. Okay? You can kind of just take my word for that. Minus, this is going to be minus 8 minus h, and we'll add 3 at the end. Then we'll distribute that 5. When I distribute the 5, these brackets all in here are going to be able to drop everything off, and we can just kind of collect like terms once we do this part. Okay? So now that we do that, we're going to be left with 5h squared plus 10h plus 5 minus 8 minus h plus 3, all divided by h. And we'll collect our like terms. Well, this is the only h squared. This h and this h can go together, and then all of our constant terms we can put together. Okay? So this will give us 5h squared. 10h minus h will give us plus 9h. And 5 plus 3 is 8, minus 8 is 0. So they cancel out, which is usually what will happen when we do this properly. Divided by h. Well, now what we do, remember our goal is to eliminate that h. We can factor h to the outside here. It's a common factor, so we'll get h 5h plus 9 divided by h. Well, the h's cancel out, so this now equals 5h plus 9. And remember, at the very beginning we said that h was a value of 0, right? That's how close it was. So we plug that in for h, and we get 9. So the rate of change at 1 is 9.